So, in the last talk, the last video, to be honest, I can't remember what I did in the last one. It was a while ago. But the table is still here. I kept this table on the whiteboard because I knew I'd be coming back to it. And we've explained how we came to these numbers, which the amount of human years in each of the 6th to the 11th plane in one celestial year. And we also know from the tables that we've seen that one celestial year is 360 days. So then we plotted these numbers going around a circle of 316 degrees. And in order to do that, if I want to show 18 human years on one celestial year, I divide it by 9 because 9's 9, and then I get 9 equal divisions of 18, so 2, 4, 6, 8, 10, 12, 14, 16, 18, full cycle is 1 year. So going around the 360 degree cycle of a celestial year in 9 equal parts, representing 18 human years, we go up two human years at each point of the 9 points. If we wanted to represent 576, then 576 divided by 9 is 64, so at each point it's 64 human years in the progression. So, and then we've got the reduced column here. This is all these numbers reduced, and that's when we saw that we had the same chains of numbers, the same sequences as you find on the magic grid. So before I take the magic star away, or the star map, just explaining one more time why this is the way that it is. We see these numbers here as 2, 4, 6, 8, 1, 3, 5, 7, 9. So 2, 4, 6, 8. I'm on the black numbers here, the very outside numbers. 2, 4, 6, 8, 1, 3, 5, 7, 9, which is exactly this sequence here. Then for the next sequence, it starts with a 4, 8, 3. So we move on to the green inner middle line here. 4, 8, 3, 7, 2, 6, 1, 5, 9, which is this sequence right here. And then we go back in the other direction to pick up the next sequence. We're starting 8, 7, 6, 5, 4, 3, 2, 1, 9. And here we're on the purple inner line. 8, 7, 6, 5, 4, 3, 2, 1, 9. And then we start again on the outer black line, but going back in this direction to pick up this sequence here. 7, 5, 3, 1, 8, 6, 4, 2, 9. 7, 5, 3, 1, 8, 6, 4, 2, 9, and so on and so forth. So we can get all the way to the top where we cycle around here the last way, and then if we wanted to, we could cycle back around the outside and come back to here. So now what I'm going to do is I'm going to reproduce this set of numbers around this Dharma wheel of 9 spokes. So 2, 4, 6, 8, 1, 3, 5, 7, 9. What's that number? 5, yeah. So this sequence plays out here. Now, the interesting thing to show you here is I'm now going to do a dot to dot, going from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 9 back to the beginning at 1. And what we have here is we have a very beautiful, what I call a regular 9-pointed star. Obviously with the star map, what we've got here is a 9-pointed star with 3 different equilateral triangles. What we've got here is a 9-pointed star, which gives a slightly different form. It's more like a classic, what I call a regular pointed star, because you can actually form this star without ever taking your pen off the paper. You just keep going and then you make the form. I talk about this in the book. It's a little hard to do here. So because the inner circle of this pointed star is really small. It's hard to work with. So I've duplicated here. This is the inner points here. These you can see the shape form here, which gives us another 9-pointed star, which is something we're going to come back to as well. But the interesting little bit that I want to talk about here is that if we add the 1 and the 9 along this line here, we get 10. So 1 plus 0 is 1. So the midpoint, I talk about the midpoint in the book. We're not really going to get into that now. I mean, we're going to see it in action here. So the midpoint along this line is a 1. And this line on this diagram, I think, is this one. So we're going to give that a 1. Okay, so we started with that one. Let's do it from the top. 5 and 4 along this straight line, that gives 5 and 4 equals 9. So that's the midpoint along that line. That would be right there, that 9. Okay, then we want to find this second triangle here, so this one here. So by doing that, we've got the midpoint between the 7 and the 6. 7 and the 6 is 13. 1 plus 3 equals 4. So we're going to put a 4 there. Okay, we want to find this next one here. So that's the 9 and the 8 together, which gives us 8 when we reduce it. We're looking for this segment now, which is the 2 and the 1. 2 and the 1 is 3. Let's dot them as I go around so I know where I'm up to. That's the 3. So we're now looking for this one, which is the line between the 3 and the 4. So 3 and a 4 equals 7. Then we're going to look for this one here, which is the line between the 5 and the 6. 5 and the 6 reduced is a 2. Then this guy here is between the 7 and the 8, which is 15 reduced to 6. We've already done the 1, and that just leaves us with this guy here to do, which is between the 2 and the 3. Add them together, we get 5. So we now, first thing to note is that we do have another sequence of numbers starting 4, 8, 3, 7, 2, 6, 1, 5, 9. 4, 8, 3, 7, 2, 6, 1, 5, 9. So we have now gone up into the next plane. And we also know that we also have a full representation of numbers between 1 and 9 here. Similarly, if we do our dot to dot in numerical order, 1 goes to the 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, bit wobbly, 6 to 7, have you guessed what it is yet? 7 to 8, 8 to 9, and 9 back to 1. And this of course is now actually, again, let's do it in a different colour so it's more obvious. That's what we've just done, basically. We've created that blue star here, but it's here in green. And we're going to work with the same principle again, only this time we're going to take the middle numbers of this star here, this what I call the expanded 9-pointed star. This is your regular 9-pointed star with the more acute angles, and then this is a more expansive 9-pointed star, which again also can be drawn without taking your pen ever off the paper. So 5 and 4 equals 9. 7 and 8 is 17, which reduces to 8. 4 and 3, 7. 8 and 7 gives me 6. 3 and 2, 5. 6 and 7, gives me a 4. That's a really bad 4. And there she is. 4, 1 and 2, 3, 6 and 5 give me a 2. 1 and 9 give me a 1. So now we have a new sequence of the 1 to 9 numbers. 8, 7, 6, 5, 4, 3, 2, 1, because we've just moved up onto the 8th plane now. 8, 7, 6, 5, 4, 3, 2, 1, 9. Okay, so now it's a little bit more obvious where we're going with this one, because all the numbers are in numerical order. So I'm just going to make life easier for myself, just mark off midpoints, more or less. This is not geometric precision here, but 1 to 2, we're doing a dot to dot numerical order, just like we did last time. And back to the 1 again. So remembering here, we also had this 9 is up here somewhere. You know, you got the extensions of, so we've got our 9, our 9, our 9 of the 3 points of the 9 pointed geometric forms, because now we're not talking about a star anymore, we're talking about a 9-sided polygon. So regular 9 pointed star, expanded the green 9 pointed star, and now we've got a polygon, the blue polygon in the middle, and we can keep going again. Let's take my midpoints here. I mean, now you may have guessed where we're going to go with this one, but this is a key moment. For the whole teaching, this is a really key moment. So let's do this one whatever and see where it goes. So the 9 and 8 is 17. 1 plus 8, 1 plus 7 equals 8. 1 plus 9 is 10, reduced to a 1. 7 and 8, that gives me a 6. 1 and 2 gives me a 3. 2 and 3 gives me a 5. That's a 7. This is a 9, a 2 and a 4. So you've now seen where we're going with this, because now for the next form the 9 has inverted. The 9 is now down at the bottom. It may not be a surprise when you look at the number sequence that if we again go from the 9, 7, 5, 3, 2, 7, 5, 3, 1, 8, 6, 4, 2, 7, 5, 3, 1, 8, 6, 4, 2, 9, back to the 9 at the bottom. So we're into plane 9 here, and as we go into plane 9, the 9 flips. The 9 is no longer at the top of the circle, so that's an important element to keep in mind. But also, this sequence is the exact same as this sequence, which I call the binary or evolutionary sequence, because this represents the cell pattern of cell development as it duplicates from a simple set 2, 4, 6, 8, 16. 1 plus 6 is 7. 32, 5, and the 1 is the 64. So we're not including the 3, 6, 9 in that cell multiplication pattern. So for that reason I call this the evolutionary sequence, which is exactly the same as this sequence. These two sequences are the same, reversed, so that's plane 7 and 10, and planes 8 and 11 are also the same. These are the more numerical sequence, 1 to 8 in the order that we commonly use them, and that's the reversed 8 till 1. So let's come back. We're now on the 9th plane. We've got our 9th plane numbers, and this pattern, because we know it's the same as this pattern, it won't be any surprise to know that what we're going to draw here is So we know it's the same sequence, so we know it's going to give us the regular 9-pointed star. And without perhaps going right the way through all the sequences, I can tell you simply that when we take the midpoints of these sets of lines here, we'll get the sequence for plane 10, and in this case it will be on the so what we're going to get here, the 9 is inverted at the bottom, and what we would get here, I'll do it anyway, I'll do it by hand, freehand, just to make the point and also to show that it can be drawn without taking the pen off the paper, because then we could just continue, and you can continue these shapes infinitely. Of the 3 9-sided geometric shapes that we're presenting here, the regular star, the expanded star, and the in blue here, the enagon or nonagon, you can just keep going round, round, round. So this, for plane 9, the 9-pointed regular star has got the 9 at the bottom. It would be true when we take the midpoints of this, that the expanded 9-pointed star, which represents plane 10 and would have this sequence of numbers, also has the 9 at the bottom. And then if we were to take the midpoints here, the 9 would once again be at the bottom here, and what we'd be doing there is drawing another enagon with the 9 at the bottom, and that would be representing plane 11. So another interesting point just to point out for you is that what's happening is, because we're taking the midpoints here, we get the expanded star inside, and then if we continued, we'd have had the enagon inside the expanded 9-pointed star. And then if we'd gone through the sequence again, we'd have had the now upside down 9-pointed star inside that, and then we'd have had the expanded 9-pointed star inside that, and the inner enagon inside that, right in there somewhere. So it's one star inside the next star, inside the next star, inside the next star. So the stars are getting smaller and subtler at each stage. Let's get rid of all this for now, and then I can just show you briefly that this is the that's the 9-pointed star. This is the that's the expanded 9-pointed star. This is the polygon, if you like. Then we got the 9-pointed star like that. We got the polygon, the expanded 9-pointed star, and the enagon. I mean, you know, when we look at a circle on a computer screen, it is actually a polygon with loads of little just straight dashes, and there are just so many of them that it kind of looks like a circle. But that's my polygon. So I feel like that's kind of covers the technical side of how these numbers break down, the link with the Dharma wheel of having 9 spokes on the celestial year, and the geometric forms that they make. There is a little bit more to expand on that, but it would need to be for another video where I've got a bit more time. But also I feel we need to talk a little bit about what this means in terms of meditation, in terms of practice. So I'm going to do that in a moment. And if you just wanted to tune in for the more technical aspect, well, thanks for looking at this video. Thank you.